And examples of chemical weathering. I really like this one. There's a reaction with water where you can see that there's dissolving going on. There's a reaction with oxygen where there's red iron going on. There's a reaction with acid where it literally got dissolved, the ground got dissolved. In reaction with organisms, which would be basically lichens and mosses around rocks. It says there are 3 types of weathering: mechanical, biological, and chemical. Mechanical weathering is caused by wind, sand, rain, freezing, thawing, and other natural forces that can physically alter rock. Biological weathering is caused by the actions of plants and animals as they grow, nest, and burrow. Chemical weathering occurs when rocks undergo chemical reactions to form new minerals. Water, acids, and oxygen are just a few of the chemicals that lead to geological change. Over time, chemical weathering can produce dramatic results. So this is chemical weathering from water. I just love this picture of this cave. Clearly, all of the rock that was here is dissolving and has dissolved. Water causes both mechanical weathering and chemical weathering. Mechanical weathering occurs when water drips or flows over rock for prolonged periods. The Grand Canyon, for example, was formed to a large degree by the mechanical weathering action of the Colorado River. Chemical weathering occurs when water dissolves minerals in a rock, producing new compounds. This reaction is called hydrolysis. Hydrolysis occurs, for example, when water comes in contact with granite. Feldspar crystals inside the granite react chemically, forming clay minerals. The clay weakens the rock, making it more likely to break. Water also interacts with calcites in caves, causing them to dissolve. Calcite in dripping water builds up over many years to create stalagmites and stalactites. In addition to changing the shapes of rocks, chemical weathering from water changes the composition of water. For example, weathering over billions of years is a big factor in why the ocean is salty. All right, chemical weathering from oxygen. Look at these beautiful rocks. You see the red is really from iron in the soil or rock oxidizing. So oxygen is a reactive element. It reacts with rocks through a process called oxidation. One example of this type of weathering is rust formation, which occurs when oxygen reacts with iron to form iron oxide, rust. Rust changes the color of the rocks. Plus, iron oxide is much more fragile than iron, so the weathered region becomes more susceptible to breakage. Chemical weathering from acids. So this is a picture of a statue, and you can see kind of from the statue, some of those minerals are dissolving and dripping down the wall. When rocks and minerals are altered by hydrolysis, remember that's water, acids may be produced. Acids may also be produced when water reacts with the atmosphere, so acidic water can react with rocks. The effect of acids on minerals is an example of solution weathering. Solution weathering also covers other types of chemical solutions, such as basic rather than acidic ones. One common acid is carbonic acid, a weak acid that's produced when carbon dioxide reacts with water. Carbonation is an important process in the formation of many caves and sinkholes. Calcite and limestone dissolves under acidic conditions, leaving open spaces. There's also chemical weathering from living organisms. Oh, look, this is under the dock or a pier on an ocean, and look at all these living things clinging to the posts of this dock. Living organisms perform chemical reactions to obtain minerals from soil and rocks. Many chemical changes are possible. Lichens, that's how that's said, lichens can have a profound effect on rock. Lichens, a combination of algae and fungi, produce a weak acid that can dissolve rock. Plant roots are also an important source of chemical weathering. As roots expand into rock, acids can change the minerals in the rock. Plant roots also use carbon dioxide, thus changing the chemistry of the soil. New, weaker minerals are often more brittle. This makes it easier for plant roots to break up the rock. Once the rock is broken up, the water can get in the cracks and oxidize or freeze. Frozen water expands, making the cracks wider and further weathering the rock. Animals also affect geochemistry. For example, bat guano, or bat poop, and other animal remains contain reactive chemicals that can affect minerals. Human activities also have a major impact on rock. Mining, of course, changes the location and condition of rocks and soil. Acid rain caused by pollution can eat away at rocks and minerals. Farming changes the chemical composition of soil, mud, and rock. If you want to watch this video, you're more than welcome to, but you have to use the link above. All right, that's it for this reading.